Okay, let's dive into this. Welcome to The Explainer. If you've been looking to just cut through the noise and finally understand the foundational bedrock of our entire modern economy, well, you are in exactly the right place. Today, we're exploring a massive, massive transformation. We're looking at how the chemicals industry has evolved from this basic, old-school alchemy into the highly precise, completely invisible engine of our global food and tech security. And honestly, there's a really special energy in the air for this one because today serves as the grand finale of our 13-day Deconstructing Industry Reality Check series. Here's our roadmap for this grand finale. We're going to start off with Section 1, the invisible engine. Then Section 2, high-tech molecular engineering. From there, we'll move right into Section 3, fueling food and tech, followed up by Section 4, the circular chemistry era, and finally, Section 5, a technology-driven future. All right, let's start right at the foundation with Section 1, the invisible engine, from alchemy to innovation.
You know, over the decades, chemical science has completely woven itself into our healthcare systems, our energy grids, practically every facet of modern life. Yet, it's still so vastly misunderstood. And this brilliantly illustrates the shift we're talking about. The old perception of the industry is just churning out commodity chemicals, right? Just giant factories mixing stuff together. But the new reality, it's completely different. This sector has transformed into a hub of high-precision molecular engineering. It is literally a highly sophisticated powerhouse that is driving the global economy. Now, to truly appreciate this new reality, we need to do a quick historical sprint, because these specific milestones fundamentally altered the course of human history. Way back in the 19th century, massive breakthroughs in synthetic dyes effectively birthed the modern chemical industry. Then, hit 1909. This is a huge one. The Haber-Bosch process revolutionized large-scale fertilizer production. I mean, it fundamentally changed global agriculture and, quite frankly, allowed the Earth to support billions more people. No big deal, right? Fast forward to today, and we're experiencing another leap forward of that exact same magnitude. AI, automation, and precision engineering are just entirely reshaping how the sector researches, produces, and distributes.
Let's move to Section 2, high-tech molecular engineering, and see how this builds, moving far beyond basic commodities. The industry isn't just making things faster anymore. It is fundamentally changing what it produces. It's wild. Modern chemistry is, for all intents and purposes, a cutting-edge tech sector. Chemical firms are expanding into hyper-specialized materials that are absolutely required for the advanced batteries powering our electric vehicles. They're creating the ultra-pure chemicals you have to manufacture semiconductors. They're engineering high-performance cooling systems. Think about it. Your smartphone, your EV, the massive data centers processing the internet, none of that advanced hardware exists without the specific molecular engineering happening in this industry right now. No way. Now, what's really interesting about this slide is how the industry is managing to achieve this incredible level of complexity. The secret? Artificial intelligence. AI is now acting as this powerful operational layer across every single step of the value chain. It starts with AI-driven molecular design right in the lab, moves to plant optimization on the factory floor, involves rigorous safety monitoring, and caps off with supply chain efficiency. Basically, AI is actively reducing friction and driving up productivity across the whole shebang. Which brings us to Section 3, fueling food and tech, meeting global demand. Okay, we've talked a lot about the science and the factories, but let's connect these molecules directly to your everyday life. Because the stakes here, they are monumental. On one side of the coin, we have our advanced digital infrastructure, the cloud, the servers, the whole AI boom. They absolutely demand highly specialized chemical inputs just to function and avoid overheating. And then on the exact other side, we have global food security. Feeding a growing planet still relies incredibly heavily on the continuous innovation of fertilizers and agricultural science. So when you think about it, our daily data and our daily bread are both fundamentally tethered to this single invisible industry. And why this matters so deeply is that global demand is surging, but our resources are finite, right? We just have to be smarter. And the industry is stepping up by radically improving efficiency and reducing waste. They're doing this through heavy automation, incredibly data-driven manufacturing, and precision application methods in agriculture. That means fertilizers are used exactly where and when they're needed, down to the inch, alongside high-end agricultural biotechnology. These tech-driven methods are successfully improving factory productivity while at the exact same time working to minimize the environmental impact. Let's shift gears and look at the hurdles. Section 4, the circular chemistry era, the green challenge. Because look, this rapid transformation, it is not without friction. The spectacular growth and innovation we've discussed so far brings some really significant hurdles. and how the industry responds to them is going to dictate its survival. So the crucial point is understanding these obstacles. The chemicals sector is incredibly energy intensive, it carries a massive environmental footprint, and maintaining supply chain resilience in a super volatile world is, well, incredibly difficult. These three factors right here are the defining challenges for the next phase of growth. And the definitive answer to those massive challenges? Circular chemistry. Now, I want to be clear, this is not just a corporate buzzword. It's a fundamental restructuring of how the entire industry operates. Circular chemistry means completely shifting away from that old take, make, dispose model. Instead, it's an approach deeply focused on recycling molecules, utilizing renewable feedstocks instead of fossil fuels, and developing inherently sustainable chemical processes from the ground up. It is literally the only viable path forward for the future of the industry's transformation.
And that leads us to our grand finale, Section 5, A Technology-Driven Future, the 13-day series finale.
You see, this evolution we've been talking about, it isn't happening in a vacuum. The molecular foundations we've explored today are the very building blocks for everything else we've covered in our 13-day Deconstructing Industry Reality Check series. It's like a giant puzzle. Over the past 13 days, we've explored the foundations of our global economy, spanning agriculture, infrastructure, healthcare, technology, mobility, and energy. Every single one of these sectors is transforming in its own unique way. Yet, what we've discovered on this journey is that they're all deeply, deeply interconnected by a broader, unstoppable shift.
Across all 13 industries, including the chemical sector we dissected today, we found the exact same DNA for success. The next era of growth, unequivocally, is going to be shaped by these four critical pillars: intelligence, resilience, sustainability, and speed. Whether you're designing AI-driven molecules in a lab, building smart energy grids, or revolutionizing global supply chains, these four factors are what will dictate how all modern sectors survive and thrive tomorrow. Which brings us to this incredibly powerful realization. The future is not a distant concept. It is actively being built today. The invisible engines are running, the molecular foundations are being laid, and these massive technological leaps are happening right now in real time all around us. I really just want to take a moment to sincerely thank you for joining me on this 13-day journey. Your focus, your curiosity, that's what makes this Explainer series possible. I want to leave you with one final thought to carry with you. As these 13 industries continue to weave the highly interconnected web of tomorrow, what will intelligence, resilience, sustainability, and speed look like in your own life? How are you going to adapt to the invisible engines powering our world? Keep asking the big questions, keep deconstructing the reality around you, and as always, stay curious.